Good evening. BMLS upgrading. Welcome all. Keep is telling me that he's waiting for the link. And I said we should join live on our channel. Come live on channel. Keep right there. Kindly come live on channel. Come live on channel. Welcome all. Welcome all. Come live on channel. Keep, it's you I'm sending message to. I can see we are 11. If you come live on channel, I told the students that we should subscribe so you can come along with another person who has subscribed. BMLS upgrading. Upgrading BMLS. Keep, I'm waiting for your response. Thank you. I can see he has responded. Welcome, BMLS upgrading. Only for BMLS upgrading. I welcome everyone who might see the link showing live. Yes, Karunguru Simon, thank you so much. Let's log in. Welcome, BMLS upgrading. My BMLS upgrading January group. If you are there, the other students, just say hi. We'll appreciate you. Good. I can see Serem Simeon. Hi. Yes, I'm the madam behind the voice. Now you can see my face. I always put my video off when I'm in class, but don't worry. This is me, Madam Winnie Online. Log in, just log in, please. I welcome you all. Let's do revision on carbohydrates. That is what we've done so far. We are here to pass, and we are going to pass. With all the dedication, it's going to work. So I appreciate all the students who have come on board so that we can see on how to simplify the biochem. So I appreciate this far. The other students who have already passed through the channel, I thank you so much. I thank you all. You've made it possible. So even with my BMLS upgrading January, we need to encourage them all, and all shall be well. So let's keep on logging in, coming on board live, and then you can just say hi on the chats. We are at 16, and we are always 15 class. So we'll give 10 minutes is much. We can give 5 minutes. Yes, Jane. Good, they are coming. Hi. Jane, hi. Nicholas, hi. Isaiah, Musioka, hi. Waeni, Lisa, hi. Omeno Dennis, hi to you people. Please, we give 10 minutes maximum. Minimum we can do at 5 because we need to start. Langat, Roslyn, hi. Yes, let's keep on logging in. We are always at 50 in class. So if we have Lucy Wanja, I also say hi. If we are at half, we'll be able to start, please. We are here to make an effort, and it's going to work. Whatever effort and dedication we put, God will never leave us. It will pay back. But there has to be sacrifices. We have to sacrifice our time, our good sleep, whatever. And then it will pay off. By July, you'll be smiling when you are writing the exam because the effort which we made. So I welcome you all. Please just come on board. Cecilia Bonareri, hi. Even the other students who might have seen the live and they just found themselves clicking the link, just say hi. Yes, Evia Diambo, yes. I had a blessed Saturday. In fact, I went to church. I'm a seventh day. So even when Kip sent the message, Madam, we need revision questions as you promised, I was from church, then I saw it on the WhatsApp. So I had to send it by 3:30. And I'm happy that you people responded, that you received it. Let me still say hi, Changawa Sharo. Hi, Amos. Together, we are together. Hi. Good tuned in. Irene Gashara. Hey. Judith Nzilu. Beatrice Mude. Hi. Nicholas. Hi. It's called Tech Sites Lab. We still say hi. We are at 23. We are almost starting because I know people are already tired, and Sunday, tomorrow, people are going to church. For the ones who go on Sundays and then Monday again, the routine goes. So let me introduce myself again as Madam Winnie, the face which will always do our biochemistry, the upgrading. I'm the Madam. When you are in class, I always put my video off, but this is me. Whether the face looks at you like, how is this Madam? Whether the Madam has a hair. Somebody already told me online last time, Madam, and why are you not having hair? Some of them are just people who always tease people online, but I have hair. Now I have to clarify, I have hair. And it's dreadlocks. It is my hair. So when somebody asks, Madam, you don't have a hair? I have hair. So this is me. I'm the Madam who always teaches biochemistry. So, good. Ezekiel Korir. That is the class rep. I've seen Kip and Korir. Korir, are you the class rep? I think. Just tell me there at the chat, then I'll know. I always not call you class rep, but I'll call you by your name, Ezekiel. But it's still okay. We shall move on. So I'm saying biochemistry. We are trying to simplify it on the channel. But what we always do is the introduction to biochemistry. Nyakundi, we say hi. Introduction to biochemistry. So what we do in biomolecules, or the fundamentals of biochemistry, which we do, we are introducing the biomolecules. And if you talk about introduction to the biomolecules, we are introducing the carbohydrates, we are introducing the proteins, we are introducing the lipids, we are introducing the nucleic acids. But those are polymers. I'm still saying hi, Nancy, Diaries, hi, yes. We are introducing the biomolecules, and you can't introduce the biomolecules without mentioning the building blocks. So that's why you could see in our carbohydrates, we started with the simple units known as the monosaccharides, the simple sugars. You can't hydrolyze them further because they're already simple. Then we are going to move to the disaccharides. Then from the disaccharides to the poly, now the polymer. That is what entails the carbohydrates. We are going to look at the proteins next week or this week. Before we start on proteins, we have to understand the amino acids, because they are the components of the proteins. Then to the lipids, we are going to look at the fatty acids. Then to the nucleic acids, we are going to look at the nucleotides. So basically, every teacher has its version, but my version is, you have to understand the structures. So we have to understand the structures of those simple sugars. We have to understand the structures of those disaccharides, which are built from the simple sugars. Then lastly, you have to also understand the structures of the polysaccharides. However much we have not drawn the structure of the polysaccharides, but now you understand the importance of the glycosidic bond. If somebody talks about 1,4, 1,6, where the branching point is, you'll be able to describe the structures of those disaccharides, of those polysaccharides, of those monosaccharides. So I said, just as I always say, that it's like you're building a house. You can't start from the whole house now. You have to start from the foundation, where you have to arrange the bricks one by one in an order where somebody who did masonry can understand the mathematics until it becomes a beautiful house. So you start with one brick and then you link to the other. One brick is the monosaccharide. It links to another monosaccharide. You have the disaccharides. Then at the point now you talk about the oligosaccharide, which fall under the poly, 8 to 10 glucose units, for example. But then at that point, you'll be talking about they fall under the polysaccharide. For some books, yes, Hunter, great. Hunter, I think I met Hunter in the other class. So I said the ones who are also coming in, you log in, just say hi, it's still fine. Hunter, we are fine, my dear. So what I'm saying is we are building the disaccharides. When you add another monosaccharide, another, now the polysaccharide comes in. Eric Mutembei, hello. Helen Chemonges, hi. We are on board. We are already starting. Welcome you all. So you are going to build a very big house. Yes, hunters, you are here. We welcome you. So we are going to build a very big house called the carbohydrates, but you have to start from somewhere small. So for us to talk about the polymer, we have to start with the monomers. But basically mine, we have to know how to draw the structures. So the essence of this discussion was I requested the students. For the other students, I've been doing my lectures until the end of the semester. Then we can do revision for all the topics which we've covered. So I thought if I can introduce again another version, the students have done marvelous. And I'm happy about it. And it's not my own might. It is the students' effort, the teachers' effort, and God above all. The students have done well. It is not only in this, in the metabolism, in the genetics. I thank them all. In the fundamentals, they've put their effort and it has shown marvelous performance. So that's why I'm also happy with the effort with the students put. So I told you we have to have a positive attitude. Remove the negative energy, leave only the positive energy, and all shall be well. Whatever you put, the effort which you put will not go if it's not answered or it's not paid off. So the reason why we are here today, now I came with another strategy. So after every topic, like the carbohydrates, let's have a revision. So that somebody can ask a question. Maybe they didn't get something right, but then they went further and tried to read about it. And then they'll be able to ask. Then by the time the exam comes or the cut comes, it will find when now you've already learned something which you didn't learn or which you didn't know. So that before we do the cut, we'll now do revision based on all topics. So for the amino acids and proteins together with the enzymes, we should also have another revision. Then it will stick. So when you go back and try to revise, you find things are very easy. Until now, you'll be wondering, what is Madam Winnie now setting? These things we did, this is very easy. But then only if we put an effort. So I already sent, I did send, let me check mine because I have to check from my end. Yes, we are getting you loud and clear, madam. Thank you so much, Milvin Jamib. Thank you so much. So let me go to my section where I had saved. I don't know whether I can narrow down. Let me see if I can narrow down and still be on the channel. Perfect. I think I can do both. My screen can do both. So if you look at the questions which we sent, at the chart I can see, I'll be able to see. If you have any questions, I'll be able to answer. So we are saying question 1. We are just revising carbohydrates, whatever we've covered so far. So that if something is not clear, I'm going to make it clear for the students to understand. When you go back now to revise on the carbohydrates, you'll be able to understand. Question number 1. With reference to relevant structures, distinguish the following. 1, or A, ketotriose and ketohexose. I said structures. In my exam, structures will always cover almost 90%. I don't like things which are explained. Somebody write notes, very long notes, explaining for me what a ketotriose is. No, I need structure. Just give me the structure without even explaining. Though I'll be explaining, but using structure, I'll also explain how the structure looks like. So 1A says ketotriose and ketohexose. So if you look at that question, it tries to focus much on naming of monosaccharides, the criteria. And we mentioned, and we are mentioning again, that naming of monosaccharides is based on two criteria: the functional group and the number of carbon atoms, the main skeleton. So I always excuse myself that I'm not Gen Z. If I would be Gen Z, I'll know how to draw the structures live on YouTube. But one of my students told me, Madam, you can't even attach a file there. I don't know how to do it. If I can do it, or next time it might improve, I'll be able to project and I'll be able to draw. And I'll be happy when I can draw it on board and the students can see. So it's okay. I'll just explain. If you have a pen and a paper, I'll explain clearly. Make sure you have a pen and a paper wherever you are. I hope somebody are not on the road or where they can't write. Then I'll be able to explain what we need to do in each of those questions because I need structures. So I'm saying reinforce with structures. Sure, a ketotriose, a ketohexose. We said naming of monosaccharides is based on one, the functional group. It is either an aldose or a ketose. And aldoses, if you look at aldoses, I said at carbon atom number 1, that is where the aldehyde group is, where you can see a C double bond O and another bond connected to hydrogen. And remember, I told you that carbon, if you look at the electronic configuration or atomic configuration, based on the atomic number, carbon will have atomic number 6. So the configuration will go to 2 to 4. So it means the outer shell need 4 electrons for stability. So you have to balance the bonds around the carbon. They have to be 4. So if the carbon atom number 1, aldehyde group, can confuse you with the double bond O and hydrogen, just write CHO. It's still an aldehyde group. But that is a functional group. It is an aldehyde group at carbon atom number 1. So a ketotriose, it means it has a functional group which is a ketose. It's always at carbon atom number 2. Remember, for those ketoses, at carbon atom number 1, you have CH2OH. Then carbon atom number 2 is C double bond O. Then carbon atom number 3 is CH2OH. And I told you it's very simple. However, I didn't give the examples for the aldotetrosis, the ketotetrosis, but you'll know the tetroses are 4 carbon atoms. At the 4th carbon, we'll have CH2OH. If it is a ketose, the first carbon will be CH2OH. Second carbon will have the C double bond O, the keto group. Then the third one will have the OH to the right and the H to the left. And then the last one will be CH2OH. So in this case, a ketotriose, it has a keto at carbon atom number 2. Carbon atom number 1 has CH2OH, just as the other ketoses. Then the third carbon atom will be CH2OH. So it is a keto, meaning it's a ketose. The functional group is a keto. 3 carbons, triose. It means for the ketohexose, example of fructose, you will have a keto still at carbon atom number 2. The first carbon will be CH2OH, and then it will be 6 carbons down the line. So it doesn't matter for the ketohexose whether you draw for me an L fructose or a D fructose. The main point here is I've said a ketohexose. So we'll come to the point where we are drawing the D and Ls, but at this time we are looking at naming of monosaccharides, including the functional group and the number of carbon atoms in the main skeleton. So in this case, the number of carbon atoms is the main skeleton. For ketotrioses, there are 3 carbon atoms. And then for the hexoses, there are 6 carbon atoms. But the functional group is a keto, which is always a C double bond O at carbon atom number 2. Furanose and pyranose, we are at B. Using structures. You have to draw for me structures. In fact, don't even explain a lot what I've explained here in ketotriose and ketohexose. Just draw for me the structure. The structure for ketotriose will be 1 mark. You can see each one of them is 2 marks. So you can imagine if you want to explain all those things, it will take much time and much of the marks, which is not even included here. Each of those will have 1 mark each. So it means the ketohexose, another mark. Just draw for me the structure of fructose. Ketotriose, draw for me the structure of dihydroxyacetone. And you'll get your mark. If it is an aldotriose, it means draw for me glyceraldehyde, aldehyde group at carbon atom number 1. The carbon atom number 2 will have the OH to the right and hydrogen. And then you'll have CH2OH. That is glyceraldehyde. Aldohexose, you can draw D-glucose, L-glucose, D-mannose, L-mannose, D-galactose, L-galactose. It will still be correct. Furanose and pyranose. Remember we said for furanoses, the 5 carbons, the pentoses, and fructose are going to form the 5-membered ring. But now, what I need is that 5-membered ring. But you have to put, remember we said, the OH at carbon atom number 5 for the furanoses are going to form a covalent bond with a keto group at carbon atom number 2. We are talking about that covalent bond being hemiketal, but it results in a 5-membered ring known as a furanose. So in this case, not necessarily should you draw exactly the structure of fructose as a 5-membered ring, but even if you draw for me the 5 corners, but bearing in mind that there is a hemiketal up there, I'll give you a mark. So for the person who draws fructose nicely, or even the riboses, I'll give you a mark because that is correct. So just give me the 5-membered ring. You'll get your mark. It's only 1 mark, the 5-membered ring. So in cyclic form. Then the pyranoses. It was for the aldehyde groups. So the aldoses. Remember, still, the OH, the alcohol group at carbon atom number 5, is going to form hemiacetal with the carbon atom number 1 functional group. So the hemiacetal has to show at the corner there. It can't be a corner which do not have that covalent bond. Then it results in a 6-membered ring. But remember, in all these, be it furanose or pyranose, the 6th one sit there, CH2OH sits up there. So the 5-membered ring, furanose, the 6-membered ring, pyranose. If you decide to draw for me glucose or the beta D glucose, alpha D mannose, no problem. You'll still get a mark. Only if you draw fructose in pyranose and you draw glucose in furanose, then everything is wrong. Because furanoses are always resulting in a 5-membered ring, and it is that fructose together with the pentoses. Then the pyranoses, the aldehyde group, will result into a 6-membered ring called pyranose. But then that is the OH at carbon atom number 5 forming a covalent bond with the first carbon functional group. Then it will result into a 6-membered ring known as pyranose. The hemiacetal and the hemiketal. It just looks the same as whatever you have previously there. But now you have to point to me where the hemiacetal is for the aldehydes, where the hemiketal is, where the covalent bond forms for the furanoses. That's how simple it is. Because that's why I'm saying it should be 1 mark, 1 mark, which totals to 2 marks. But structures. For me, structure speaks more than anything else. So it has to be structures. You don't need even to explain to me whatever happens. Only if it is for the polysaccharides, where we talked much about the starch, the amylose, the amylopectin, the alpha-1 or the alpha-1,6 found in plants, whatever, glycogen. Yes, that's fine. But here, when I talk about structures, I just mean structures. So, number D, we are still on question 1. L-mannose. So you are too fast. Nancy, let me ask you first. Do you have the questions? Nancy, I want you to answer me if you have the questions. And you can tell me how fast I am, where you did not get, so that I can go back. Just tell me where you didn't get. Then I'll be able to explain. I don't want to leave anybody behind. Just tell me in the chat, because we need to move together. I need to know where. Or could change your camera and we write it together. What are you writing, Nancy? That is why I sent those questions, because what I need you to do is to follow the questions, because this video is going to be available on the channel so that we can move together. Drawing. How can I draw? I already introduced myself that I'm Gen what? Is there Gen 100 centuries ago? I don't know how to draw. I even long that I could draw. How can I draw? Maybe somebody can tell me. Nancy, that is the challenge I have. I want her to tell me what she thinks, because now maybe somebody can try to make it easier for me to understand what Nancy is saying, because that is what I'm trying also. Because if I could have had a way of drawing on my YouTube, I don't know. I really don't know which app I can use. But before we do the cut, I think we shall have already had an idea. Nancy, what I'll do, let us just proceed. What I'll do, you see the questions. The hemiketal, drawing the hemiketal. Now the challenge which I have is I can't draw. Let me do this. Let me revise. Let me revise. And then by the time in 3 weeks' time, in 3 weeks' time, I'm going to break down this. I'm going to draw the structures, each one of those, and then I put in a video, which I record. Then you can see. So I'll be able to record as I draw, I explain, and then I'll post it again on the channel. Then it will be able to guide you. So I'll write still carbohydrate revision for BMLS app specifically, and then I'll be able to draw each one of those. You see, we go to question 1. I draw and I explain what should be. You get. So for now, you want to know the hemiketal. So for the hemiketal, you could see the structure of, you can draw on a book, then you turn it to face the camera. Ah, you see, Asnat has come with a solution. Okay, let me have a book. That's also fine. I think that is fine. We can manage for now. That will be fine. Let me get my book, huh? And then we can see, right? I can see a book here, but I need a pen. So just give me a minute. I think Asnat's idea is fine. Write it on a paper. Then after we write, you can show us the answer. Write it on a paper. No, we are not writing. I'm going to draw for each of them the way Asnet says. Huh? So I'll start with the first one. Huh? So you'll bear with us. Don't see that we are taking much time. I'm here for the students. So just wait a little bit. I get my pen. Yes. Now, we can go back to the first one. We can start on the first one. Are we okay with that? Even if we'll sleep late, let's sleep remain. Yes? Because we need to understand this. So, I'm saying for the keto trios, good. For the keto trios, we are saying that we have the 3 carbons. So the first one has to be CH2OH. We are saying we are naming our monosaccharides. I don't know whether you can see. Let me see. Can the camera show? I don't know. Something is reflecting. I don't know why it's reflecting. Are you seeing something like that? The first one has to be CH2OH. The second one is a keto group. So the C double bond O, I think I need to bring it closer. Just a minute. This my question thing can go down. I'll be able to scroll it. We are going to survive, don't worry. Life has to involve struggles for us to get it right. Now, there is a bit of reflection. Good. Can we see? Very good. I can see. Just respond on the chat. It's going to work. Don't worry. CH2OH. Carbon atom number 1, CH2OH. The keto group. Then the third carbon. Yes, we can see. Very good. So we are talking about naming of monosaccharides, the criteria. First, based on the functional group, the keto, that is the keto. Secondly, the number of carbon atoms in the main skeleton. Imagine I long to write it on the board. Number of carbon atoms in the main skeleton. And I said, this is the first carbon where there is CH2OH. First carbon. Carbon atom number 2, keto. Carbon atom number 3, CH2OH. It means ketohexose, 1, 2, 3, 4, 5, and then the 6th one, I'm drawing, then I'm going to show you. Then the carbon atom number 1 still is CH2OH. Carbon atom number 2 is a keto, but you can either draw a D-fructose, which I'm drawing now, or an L-fructose. It is still okay. So, look at that. I think I should put it like this. CH2OH, keto group, number 2. OH, we are drawing D. that is D-fructose. To the left, OH, put the hydrogen to the right. Characteristic of water, ideal biological solvent. It has to be OHH, not HH, not OH. OHH. Then carbon atom number 4, 5, OH, to the right, CH2OH. That is a ketohexose. An aldotriose comes like this. I'm drawing an aldotriose, an aldehyde group, an aldo. Can you even see it? My dear God from heaven. I don't know whether my students can see, but we'll have to see. The eyes have to be stretching. Here. Yeah, here. Guy. How can I put this person to go? I should put it like this. Good. You see? C double bond O H, C O H H, CH2OH. Aldehyde group at carbon atom number 1. That is an aldotriose. Criteria for naming of monosaccharides. Number of carbon atoms still 3. Functional group at carbon atom number 1. It is an aldehyde. CH2OH. It means for an aldohexose, still at carbon atom number 1. Remember, I told you if you can't balance bonds around the carbon at carbon atom number 1, an aldehyde group is also CHO. Just write CHO. It will still be fine. CHO, if you can't balance the bond. How I wish you can use marker pen. No, please don't complicate things. Where can I write marker pen on a paper like this? Is the ring light in use? If I use the ring light, it brings more light. Yes, I can use it. Somebody is asking. If I use the ring light, you can see better. Who asked? Phoebe. You know, I used the ring light and there was a reflection somewhere. That's why I put it off. Which one is easy? Is it the ring light or no ring light? I want to proceed. You'll tell me. Now, tell me if the ring light is fine. But marker pen, we can't. That one needs a very big board. Huh? But the board should be right behind me. I have a board. If I put it behind me, will we be able to see? That is what I don't know. But all this, I think, we'll be able to organize next time, so that becomes okay. So I've used the ring light. Should I put the ring light off or I should leave it on? The person who is asking about the ring light. So I talked about furanose and pyranose. Furanose, pyranose. Israel. Pyranose. Furanose, pyranose. You can see the 6-membered ring. Asnat. Yes, Eric Mutembe is saying I put it off because I think there was an extra light. And Asnat Nyakundi is saying ring light. So which is which? I still put it on. Can you see? Or I can put the ring light off. Are you seeing the difference? We are looking at the charts. I want us to move on the same direction. There is this lady. Ring light mbele. Eka ring light mbele. Mbele yangu. Is it not worse? Are you just guessing these ideas or you have used it before? because now you are even interfering with the people's concentration. What Phoebe is telling me doesn't make sense. You know, I'm going to switch it off the way this one, the other guy told me, because let me try. Is it not okay like this? It is better. Good. Now we are going to proceed. I was using the ring light and I saw it was not making sense to me. So the lady who brought this idea of writing, I was talking about the 6 member. Very good. Thank you so much. Now we can move up. So I'll be able to draw. We'll be able to get place. So the 6-membered ring is the pyranose. You can see the hexagon. Is it called the hexagon? But then you can see the covalent bond there. So the one, is it to the right of mine? But then the 6-membered ring is as a result of the aldehyde groups. So the aldoses will form a covalent bond. OH at the 5th carbon atom. It will result in a 6-membered ring known as the pyranose. So you can draw for me the pyranose without specifically drawing the beta or the alphas of those aldoses. This one is correct. The pyranose is the one which is 6-membered ring. Now, the hemiacetal, you can see that bond there, that circle which is there at the corner. That is hemiacetal. Good. Asnat says iko sawa. Then, the 5-membered ring you are seeing here is a furanose. The pentoses together with the fructose. Whatever you are seeing here is the hemiketal. The lady asked about the hemiketal here. So at carbon atom number 2, keto group, with OH at the 5th carbon atom, we'll end up forming the covalent bond, the hemiketal. So the resulting 5-membered ring is known as furanose. The resulting 6-membered ring is the pyranose. That is what I wanted to draw. Then section C talks about hemiacetal and hemiketal. The hemiacetal is for this. The hemiketal is for this. So only this one you point out here. That is the hemiketal. Point out. You know, I'm going with this one. I don't even know. Here. Hemiacetal. But then the resulting, the 6-membered ring is the pyranose. The 5-membered ring is the furanose. Simple structures. Now we are coming to D. L-mannose and L-fructose. We said the monosaccharides are drawn into 2. There is the linear ones, which are known as the Fisher's projection, and then there is cyclic ones, which are known as the Haworth projection. So if you see L, D for the monosaccharides, be it mannose, be it glucose, be it fructose, be it galactose, you have to draw the linear form. If you are talking about the beta L, the alpha L, or the beta D, the alpha D, the alpha and the beta means you have to draw the cyclic form. Now, I'm going to draw the D mannose first. I told you that the D and L's are stereoisomers. They are mirror images of one another. So, let me draw the mannose, the D, and then I can also draw the L. Then I draw D fructose and L fructose. But we should bear in mind that as much as we are drawing them, we should remember that drawing of those monosaccharides is based much on the number of carbon atoms and the functional group. For mannose, it has an aldehyde group, so it is an aldose. Secondly, mannose has 6 carbon atoms, so it is an hexose. So it will be an aldohexose. So let me draw, still on the same page. I'm drawing mannose, the first carbon atom, should have the aldehyde group, 6 carbon atoms down the line, 1, 2, 3, 4, 5. And then the sixth one should be CH2OH. For mannose, at carbon atom number 2, the OH for D-mannose, to be sure, the carbon atom number 2 and number 3, the OH is to the left. It means carbon atom number 4 and number 5, it has to be to the right. So that is D-mannose. You look at that, we have D-mannose there. Why is it not coming the way I want? Am I the one with... Oh, my book is too small. I should get a big book. Let me check my equations the other side. I think that is what is confusing me. Or I take it, then I'll bring it up. So look at this. My D-mannose. Carbon atom number 1. My D-mannose. Carbon atom number 1 has the aldehyde group. Carbon atom number 2 and number 3. OH to the left. Can you see? My people, can you see? Can you see? I should hold it up. Good. That one is better. Carbon atom number 1 has the C double bond O, has the H there. Remember to balance the bonds around the carbon. Carbon atom number 2 and number 3, OH to the left. We are drawing D-mannose to start with. Then hydrogen to the right. I said those are property of water. It has to dissolve those components which having those functional groups. Then carbon atom number 3 and number 4, put the OH to the right, put the hydrogen to the left. The last one has to be CH2OH. So it means for L-mannose, carbon atom number 1 will remain the way it is. Carbon atom number 6 will remain the way it is. Carbon atom number 2 and number 3 now, put the OH to the right. Then the hydrogen will come to the left. Then for the carbon atom number 4 and number 5, now bring the OH to the left, the hydrogens to the right. Let me draw. It's interesting, very interesting. I told you don't cram, master. If you cram, you will see fire without smoke. Let us master. 1, 2, 3, 4, 5, 6. Carbon atom number 2 and number 3, we bring the OH to the right. Carbon atom number 4 and number 5, you bring OH to the left. And you have L-mannose. L-mannose. Look at L-mannose, the one which is close to D. Now, whatever which was to the left, bring to the right. Whatever which was to the right, take to the left. But retain carbon atom number 1 and number 6. Let it remain the way they were in D-mannose. Simple. Imagine, simple. Very simple. Structures. L-fructose. 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 You can see the exercise book which I'm using. This was for my baby class, the one who is now in PP2. I don't know whether the book was used until, that is what I could find close, but I still have a book I'll be able to write, don't worry. So we'll start with D-fructose. D-fructose. Carbon atom number 1, CH2OH. Carbon atom number 2, C double bond O. Carbon atom number 3, put the OH to the left. Hydrogen, right. Then put the OH at carbon atom number 4 and number 5 to the right. Then number 6 is CH2OH. Master, don't cram. I told you, if you see it, just master how it is. Carbon atom number 1. In fact, ketosis, drawing them is very easy. You don't interfere with 1, don't interfere with 2, and don't interfere with 6. Carbon atom number 3, OH to the left, put hydrogen to the right. Carbon atom number 4 and number 5, OH to the right, put the hydrogens to the left. Then you will have D, fructose. For L, fructose is simple, very simple. Leave carbon atom number 1, number 2 the way they are. Carbon atom number 6 the way it is. Carbon atom number 3, take the OH now to the right. Then bring hydrogen to the left. It means 4 and 5, bring the OH to the left and then the hydrogen to the right. Then you have L, fructose. So far, so good. Are we moving on well? We are managing. We are not even moving on well, but we are managing. Eh? L, galactose. L, glucose. I haven't drawn glucose. I'm going to draw glucose. I haven't drawn galactose. I'm going to draw galactose. Then now, L will be easy. After drawing, I'll just mention how the L looks like, because you are not going to interfere with 1, you are not going to interfere with 6. We are just going to play around with carbon atom number 2 to number 5. Let me draw glucose. I start with galactose or glucose? Glucose. Carbon atom number 1, I'll put the simple one now, CHO, so that the ones who can't balance the bonds around the carbon, for confusion for number 1, we can also write CHO. Both of them are aldoses, so you just write CHO. Carbon atom number 2, I'm drawing glucose. The OH is to the right. Carbon atom number 3, I'm drawing D to be precise. The OH is to the left. Carbon atom number 4, OH to the right. 5 to the right, and then the last one, CH2OH. I have drawn D glucose. I have drawn D glucose. I have drawn D. I have drawn D glucose. Look at that. CHO. If you can't balance the bonds around the carbon atom number 1, don't get stressed. Put CHO for aldehyde groups is the same. Carbon atom number 2, the OH will be to the right. It means for D-glucose, just check on carbon atom number 3. Put the OH to the left, then hydrogen to the right. Then for number 4 and 5, now you put the OH to the right and then the hydrogens to the left. The last one is still CH2OH. That is D-glucose. For L-glucose, it is simple. It is a mirror image of one another, D and L. So the mirror, you know, the first carbon will not give us the mirror image, because mirror is when you look at yourself, whatever was to the left now is to the right. It will only work for carbon atom number 2 to number 5, because 6 will remain the way it is. So for carbon atom number 3, you will shift the OH to the right and then bring the hydrogen to the left. Carbon atom number 2, you'll take the OH to the left. Carbon atom number 4 and number 5, you'll take the OH to the left and then the hydrogens to the right. Focus the glucose structure on the light. I was to confirm something kindly. Which one? The one which I've just drawn. Are you seeing it? Why is it not showing? Even from my end, I'm not seeing it. Who is the lady who is asking? Phoebe, did you see what you are focusing? What did you want to see? So that you can also tell us if I've drawn it wrongly. How did you know it until what you saw is different? Can you tell us what you are focusing so that we can also learn? And have you seen it clearly? Is there something which you didn't get? Can I bring it here? Phoebe, can you see? I want you to tell me if you can see. Uh-huh. Yes. No, you can't tell us yes, thank you without. You see, Irene is saying not visible. Irene, can you see it now? Irene, I'm waiting for your chat. I'm waiting for your response. The last one. Asnath, what is the last one? Are you explaining to who? To Irene? Phoebe, what did you want to see, which you have seen, and say yes? Because we also have to learn. We are learning. So maybe there's something which was not clear on your end, and now you've realized it's clear. You can just highlight so that the other people who also didn't get to get. Phoebe, what did you not get, which you got, so somebody can also pick? I'm at Phoebe Kanini. You said I should focus on D-glucose structure on the light. I want to confirm something kindly. What did you want to confirm? So that the other people can also understand. Phoebe, I'm on to you. I want you to answer me on the chat so that I can proceed. The OH on carbon atom number 2 and number 3. Okay. But remember, the oxygen should be close to the carbon than the hydrogen. You know what I mean? I've put the oxygen inside, not the hydrogen first. So the hydrogen should be outside and then the oxygen inside, because the oxygen tells much about hydrophilicity. The hydrogen will always contribute much to hydrophobicity. So it's always good when you put the oxygen close to the carbon than hydrogen. So some students will bring the hydrogen in and oxygen outside. It even looks weird. As much as it's still correct, I'll not give you a wrong because it's still an OH. But putting the oxygen inside and then the hydrogen out. As I think Irene Gashara, now you've seen, I think Asnat was answering Irene's concern. So it's a matter of bearing in mind naming of monosaccharide. Very important. You have to put in mind, you know, it's a ketose, it is an aldose, it has 3 carbons, it has 4 carbons. Everything will be right. And then you have to know that when you are drawing D, which of the OHs, which hydrogens should I put to the right, to the left? It will be fine. And especially when you look at the OH, for something like fructose and glucose, it's simple. The OH for D has to be to the left, and then you put the hydrogen to the other side. But now, some like mannose and galactose, since they will have a term which we call themselves in relation to glucose, like the epimers, leave alone the functional isomers, which we talk much about when you compare the fructose and glucose. For this mannose and galactose, there is a reason why at carbon atom number 4, together with carbon atom number 3, the OH will be to the left. For mannose, as much as at carbon atom number 3, the OH is already to the left, but now together with carbon atom number 2, the OH will be to the left. So there is something unique. But then that carbon atom number 3, for glucose and fructose, if you're drawing D, just go straight and put the OH to the left and put the hydrogen the other side. It means the other carbons, if it's not carbon atom number 1 and number 6, then they will be to the right. Simple. Then the mirror image. Whatever was to the left, just shift it to the right. And whatever was to the right, put it to the left. But don't interfere with carbon atom number 1 and number 6 for the aldoses. Don't interfere with carbon atom number 1, number 2, and number 6 for the ketoses or for the ketohexoses. Simple as that. And then you'll find things very easy. So I promised to draw galactose. I promised to draw galactose because I hadn't drawn it. Galactose, it is also, I think I'll draw it in a fresh page so that the students can see. It is also an aldose. 6 carbons, 1, 2, 3, 4, 5, 6. At carbon atom number 3 and number 4. For D, I'm drawing D, galactose. Put the OH to the left. Carbon atom number 5 and number 2. Put OH to the right, and we have D, galactose. Why is it looking dim? I don't know. But let's see whatever is there. Phoebe, Irene, I hope you people can see. Carbon atom number 1 has the aldehyde group. It is 6 carbons, hexoses. Yes, I think it's better if I draw them each on their own page. It becomes clear. Carbon atom number 1, if you can get stressed in balancing the bonds around the carbon. Thank you so much, Shama. So carbon atom number 6 remains CH2OH. Thank you so much. I think it's clear if I draw each on their own page, which is fine. CHO, that is aldehyde group, 6 carbons. It is an hexose. Do 6 carbons down the line. The 6th carbon remains the way it is. CH2OH, 1, 2, 3, 4, 5, 6. But now we said for galactose, D-galactose to be precise, at carbon atom number 3 and number 4. I repeat, galactose is an aldose, an aldehyde group at carbon atom number 1. 6 carbon atoms, hexose, meaning it's an aldohexose. The 6th carbon is CH2OH. But at carbon atom number 3 and number 4, the OH is to the left for D-galactose. Put the oxygen close to the carbon. Oxygen inside, hydrogen outside. Balance with the hydrogen the other side. Still characteristic of water. Then go to carbon atom number 2 and number 5. Put the OH to the right, hydrogen to the left. D, galactose. And that is why if you looked at the structure of D-glucose, only at carbon atom number 3, the OH was to the left. But in this case for galactose, both carbon atom number 3 and number 4, meaning the LCM here is carbon atom number 3 for both of the monosaccharides. The common factor here, is it the LCF or the LCM? I don't know. The common factor here is carbon atom number 3. But there is a change at one carbon, which is carbon atom number 4. That is why D-galactose and D-glucose are epimers. It means who is the epimer of one another. The galactose is the epimer, is the one which has the difference. The reference point is glucose here. So D-galactose is an epimer of D-glucose at carbon atom number 4. And who are these epimers? They have the same molecular formula. They are of the same functional group. They are both hexoses. C6H12O6. They are both aldoses, aldehyde group at carbon atom number 1. But there is a change at a specific carbon atom, which is not the carbon which carries the functional group. You didn't see, it doesn't touch carbon atom number 1. It touches any other carbon, not 1, not 6, because 6 is already CH2OH. And that carbon which it touches is carbon atom number 4. So that's why we said galactose is an epimer of glucose at carbon atom number 4. But there are epimer pairs. Which of the following are epimer pairs? Glucose, and galactose. Galactose and mannose. Galactose and fructose. None of the above. Pair. If it's galactose, there has to be glucose inside. If it's mannose, it has to be having glucose inside. That's why we also said D-mannose and D-glucose are also epimers at carbon atom number 2. That is what epimers are. So, you've seen the structure of galactose means L-galactose to draw is very simple. Retain carbon atom number 1 the way it is. Leave carbon atom number 6 how it is. Leave it. Carbon atom number 2 and number 5. Shift the OH to go to the left. Hydrogens to the right. 3 and 4. Now shift the OH to go to the right. Hydrogens to the left. Simple. No cramming, no more Kenya. My friend, if I find you with Kenya, I tear your paper and I give a 0 for the cut. Simple. Because we can't make all this effort and then you go and try to measure my head and this madam doesn't know me. I'm going to have this small thing which looks like oxygen of mine. I'm going to write structures. Start now to master the structures. It will be very easy. We just have to understand how the structure come about. It is very simple. That's how simple it is. If you know my secret, I just deal with structures and all things are fine. Imagine I'll give you all the marks. Even if you get a 68, which I've never seen, I've seen a 67. Because I've also seen a point where I have to reduce it. No, a 68 has been there. Only a 69 and a 70. You can't give all the marks. You'll find something to drag the student. But you find the student is very perfect. The structures are all fine. But you'll find a minor thing where he or she didn't write well. At least you have 2 less. But still the 95 still exists. They get. Because the student has got the structures right. So if we get the structures right, so if you ask the D, L, linear, don't even go and draw for me cyclic. And it's always difficult for me to set for you to draw for me L's. I'll always set the cyclic ones because the L's, I definitely set them maybe in the essays when I want to discuss using 4 structures in each examples, naming of monosaccharides based on. So I'll know you'll draw for me the linear form. Don't draw for me the cyclic form. That is where I'll see how to exercise the linear form. But it shall be well. Yes. So let's go to another one. Is that one fine? So for these monosaccharides, we know we have to draw them as much as we have to draw them in linear form because that's what we've discussed so far. Try to bear in mind how many carbon atoms are we talking about? Which of these functional group? At which carbon or at what carbon do we have this functional group? If it is D, then what should I be looking at? If it's mannose, should I look at carbon atom number 2 and number 3 for the D? Where is the OH to the left and then the hydrogens? If I'm looking at D, galactose, then what should I look at? Carbon atom number 3 and number 4, the OH to the left. And it's still an aldehyde or an aldose at carbon atom number 1. If you're looking at glucose, just go straight at carbon atom number 3. The OH should be to the left. It's still an aldehyde group. And then if it's fructose, talk about the keto. It's a keto triose, 3 carbons. But still, for ketosis, drawing them is very easy. Carbon atom number 1 and number 2 is the same for all of them. Now just play around with the OH. For me, even if it's a tetrose, you put for me the OH to the left and hydrogen to the right at the 3rd carbon atom. I won't mind because the 4th carbon is already CH2H. The 1st carbon is already CH2H. The 2nd carbon is already C-double-bond-O. Then you go to a ketopentose. For ketosis, drawing them is very easy. Already 3 of the carbons are steady. You don't even interfere with them. The last carbon, which is a pentose, if it's a pentose 5 carbon, has to be CH2H. First and the second already CH2H and C keto group. So just play around with the OHs at carbon atom number 3 and number 4. Whether you place to the left or to the right, I won't give you a wrong. because already you've explained to me clearly, the student has an idea that a pentose has 5 carbons. A ketopentose has a keto group at carbon atom number 2. The carbon atom number 1 for the ketosis will still be CH2OH. The last carbon is CH2OH. Why would you give the student a wrong? No, the student has much idea on what they are drawing. Let us see. I'm going back to my questions. If somebody has a question, maybe I can also try to answer it. So I'm going to G, which now talks about the cyclic form. You know, as much as we are covering this, you'll realize that we are covering a lot at a go, such that when I reach naming of monosaccharides, the criteria, you shall be able to understand what I mean, because the structures have already drawn them. So we'll be able just to refer to some of the structures which we drew. If we talk about the functional isomers, the epimers, so we'll be able to refer to such. Now, we have been told to draw beta L fructose, alpha D glucose. I told you that when this question is asked, beta alpha, fructose, glucose, the first thing which you should bear in mind here is we are drawing beta L fructose. Fructose, together with the other pentoses, are forming a 5-membered ring. Start by putting the 5-membered ring like this. Let me narrow this my thing down, please. We are now in serious business. Do something like this. Straight. You have fructose. You have the pentoses, the ribose. Do something like this. The pentoses and fructose will give us a 5-membered ring, the furanose. Start by doing something like this. The next point is simple. They are talking about beta. Let me tell you the next point. Beta, OH above, OH above. That is what we learned. OH above, beta. We said carbon atom number 1 in the cyclic form. It is the one which determines the beta or the alpha. Beta, the OH above at carbon atom number 1. That is the CH2OH, such that you say 1. You know, I'm working with this, my thing. 1, let me show you. 1, 2, 3, 4, 5. And then the 6th one will sit up here. The 6th one, you don't interfere with it. Look at the 6th one. The hydrogen will sit down here, because remember, there is hemiketal. You see, the hydrogen, which is always left, will be left there. The OH will form the hemiketal. If you start by drawing it like this, it makes your work easier. Now, if you already know how to draw the linear form, move your book lower. Shama is saying, I move. Shama, can you see? Sorry. Lower and closer. Shama, I need a report from you. Can you get? I'm waiting for Shama to respond. Shana, you are the one I'm waiting for. I've been calling you Shama. I had one of the nursing students who was a guy and was called Shama. That's why I'm saying good. Thank you. Thank you. Yes. I like when you move together. So I'll be able to see the charts and then we'll be able to move together, please. Let us not get tired. It's still okay. We'll be able to get something. Now, I said for beta, L. Is it L? L fructose. First, if you see fructose, they will result into a 5-membered ring. Remember the hemiketal up there? And then the next point here is we are talking about beta, position of the OH. It has to be above. We said alpha is below. So above, then the sixth one sits up there. That is the hydrogen, which is left hanging after the formation of hemiketal, with the hydroxyl group at the 5th carbon atom and the keto group. Good, as Nat can see. Now, we already learned how to draw the linear form. So, we are just going to play around with carbon atom number 3 and number 4. Imagine. You know, ketoses are always very easy to draw. What can give us a little, not too much headache, are aldoses. And you people, you'll bear me witness that for L fructose, L, at carbon atom number 3, we are going to have the OH outside the ring. Then at carbon atom number 4, inside. Simple as that. Simple as this one. Do you agree or you don't agree? Whoever do not agree to raise up their hands. You see, at carbon atom number 3, we are drawing beta L fructose. L fructose. I said we are twisting our linear in clockwise direction. But as much as you are twisting it in clockwise direction, you have to bear in mind that the fructose is going to form a furanose or a furan ring. At carbon atom number 1, we have the beta, the OH is above. But then for L fructose at carbon atom number 3, the OH was to the right. Yes, your right hand finger. Just remember the right hand, wherever it is. So when it twists, if you are looking at my hand now, if you twist, it means it will be outside the ring. Then at carbon atom number 4, since the L to the left, it will be inside the ring. Simple. That is what I need. And I'll give you 2 marks. Imagine. Here, in exam, I give this one 2 marks. This one, marks. Because for the student to think that it is a furanose or pyranose, already has an idea. You see the furanose, this one, if I see the pyranose, I give a very big wrong before I can even see the position of the OH. So when you see it's a furanose, already a tick in my head for the student. And then now I see the position of OHs at carbon atom number 1. I see how they draw the CH2OH, the hydrogen, is it in good position? Carbon atom number 3 and number 4. Are we talking about L or D? If the student put it correct, then now my take will come live physically. 2 marks. Simple as that. We are simplifying biochemistry. People talk about biochemistry is difficult. We are trying to make it simple so that we can also try to enjoy the classes. Yes. So I'm going to draw, if it was D, it was the same thing, but now the OH at carbon atom number 3 will go inside and then the hydrogen outside. Then at carbon atom number 4, the OH will come outside and hydrogen inside. If it will be beta D fructose. Just play around. But you have to know the linear form. And then if it's alpha, the OH will come down and the CH2OH up. Simple. Let us draw the 1, 4. I'm going to draw each one of them in each page so that the students can see. I think some pages are still there. So I had this one. Let us draw for any of the pyranoses. Glucose. Because the next one I'm also going to draw for the mannose. Alpha D glucose. Alpha D glucose. Just by looking at glucose itself tells you that it has to be a pyranose. By looking at glucose, the hemiacetal sits quietly there. Pyranose. Look at the sugars, the monosaccharides, the simple sugars. Is it having an aldehyde group? Is it having a keto group? Then, and you know, whatever you saw in the lectures was saying, there is no ring structure which is forming with the trioses or the tetroses. It is with the pentoses and the hexoses. So the hexoses for the aldehydes will give us a 6-membered ring, which you're seeing here. But since a ketose is present on the fructose, together with the pentoses, it's going to form a furanose. So the ring structure is only forming with the pentoses and the hexoses. So you can see, start by drawing it like this. Then the next thing, check. It says alpha or beta. Let's see. Alpha. Good. Next point, at carbon atom number 1. You see, some students miss a mark. Let me tell you the secret. Some students miss a mark by putting CH2OH there. It is not CH2OH, it is H. For aldoses, it is a H. That one is the second thing you should check on. Carbon atom number 1, the OH below, it is alpha. Then put a hydrogen up there. Already you've put the pyranose. The hemiacetal sits there quietly. If you draw the 6-membered ring without the hemiacetal, I'll not give you a mark. Then at carbon atom number 6, CH2OH, and then the hydrogen, where the hemiacetal is, sits there. Then now, play around with the OHs and Hs from carbon atom number 2, number 3, and number 4. Imagine, no cramming. Just understand how the structure comes about. So they're saying L, let me see if it's L. If it's L or D, L. And guys, we need to put a little by little. So you are the one who is going to tell me if I'm done with the alpha and beta, I can stop. Then people go sleep. Because I don't like talking too much for more than 1 hour. It means the concentration goes down. We still have enough time until the semester ends. And I can continue the other ones any other time or next weekend. So we are going to agree. Let me go back to my question. Alpha D glucose. It is good if the students understand polypoly. The world is not ending today. Me, I always say I don't want stress in life. And I don't even like it. And I don't like to put it on students. You understand bit by bit. It is good if we swallow it. So we are saying D glucose. Alpha D glucose. At carbon atom number 2, for the linear D glucose, you could remember the OH was to the right. So the OH will come outside the ring. At carbon atom number 3, the OH was to the left, so it comes inside the ring. At carbon atom number 4, it was at the same position as carbon atom number 2. Imagine, this is what we need to draw. I'll bring it closer and closer. There is a reflection there, here in the middle. I don't know if other people can see it. Can we see? Look at that now. That is an alpha. Alpha because at carbon atom number 1, the OH is below. But then it is glucose forming a pyranose. You ready to draw a 6-membered ring? Hemiacetal sitting quietly there. Carbon atom number 6, don't touch. Carbon atom number 1 tells us the beta and the alpha. If it's above, it's beta. Below, it's alpha. Thank you so much. I can see you are seeing it clearly. At carbon atom number 2, the OH is outside the ring because we are drawing D-glucose. In the linear form, our D-glucose at carbon atom number 2 had the OH to the right. At carbon atom number 3, it was to the left. So it will stay inside the ring. Then you put the hydrogen. Then it means carbon atom number 4, the position is the same as carbon atom number 2 because it was to the right. So look at the position, that position. Simple as that. That hydrogen you are seeing there inside is the hydrogen which remains hanging where the covalent bond forms, the hemiacetal. Look at how interesting it is. Don't get stressed. When you see beta, alpha, draw for me the disaccharides. No, don't get stressed. We are going to simplify. And that is why we are here, to simplify biochemistry. So, I'm going to draw beta L-mannose and beta L-galactose because even question number 2 relates to whatever we've been doing, the linear and the cyclic form. And then I want you to answer me in the chat because I don't like talking, and maybe the students are already tired. That is why I don't like to talk more than 1 hour. So it is better I do it in bits until we get it right. So as I'm going to draw the structure of beta L-mannose, beta L-galactose, you'll tell me in the chat. Because of course, the world is not ending today or today night. We are not having exam tomorrow, but it's good to start early for the revisions. Such that now when you go to your notes and you try to understand the cyclic and the linear, it will be very easy. You'll be wondering what Madam Winnie is setting now. Now, for me to draw mannose, I already know mannose is an aldehyde. It is going to form a 6-membered ring. We are drawing beta mannose, OH above at carbon atom number 1. I'm going to show you what I'm drawing. Carbon atom number 6 sits quietly up there. The hydrogen at carbon atom number 5 hanging inside. It's already formed the hemiacetal. We are now playing around. We are now playing around with carbon atom number 2, number 3, and number 4. Now, we are drawing L-mannose, but then a beta L-mannose at carbon atom number 2. For D-mannose, the OH at 2 and 3 were to the left. But now, L is a mirror image of D. So it means at carbon atom number 2 and number 3, the OH are to the right, sorry. So it means our OHs at carbon atom number 2 and number 3 will be outside the ring. Then put the hydrogens inside the ring. It means at carbon atom number 4, the OH will be in that position. Look at that. The mannose already 6-membered ring. Hemiacetal. Carbon atom number 1, it is beta above the ring. Carbon atom number 2 and number 3 for L-mannose, they will come outside the ring. Look at the position of carbon atom number 4. It will be opposite whatever is in 3 and 4, 2 and 3, sorry. And then carbon atom number 6, we have CH2OH. The hydrogen at carbon atom number 5 will sit quietly there. Imagine that is beta L-mannose. It means if you have to draw alpha D-mannose, for alpha, you'll put the OH at carbon atom number 1 down. Hydrogen will go up. But since it will be D-mannose, at carbon atom number 2 and number 3, the OHs will be inside. Then bring the hydrogens out. It means at carbon atom number 4, the OH will come down and the H will go up. Simple. The other ones will remain the way they are. CH2OH, hydrogen inside. The hemiacetal will remain the way it is. Changawa Charo. I don't know what is writing there. But now, I'm going to draw the last one because I want to, or should I ask Korir? Korir, I need to leave the students to go and swallow whatever we've drawn, the linear, the cyclic. And then they should bear in mind the number of carbon atoms. Secondly, the functional group. And another point, can they draw linear and cyclic? Even any of those which you've learned, it will be easy to draw. I'm drawing galactose. I'm drawing galactose. So we said here it's saying, which one? Beta L galactose. Beta L galactose. Galactose is also an aldose. Draw the 6-membered ring. Beta, the OH is still above. At carbon atom number 6, we have CH2OH. It doesn't change. The hydrogen at carbon atom number 5, which has formed the hemiacetal. But now, look at straight at carbon atom number 3 and number 4. The OH for L will be outside the ring. And then at carbon atom number 2, it will be inside. Imagine. That's how simple it is. I'm trying to make it closer. I think we can see. So I have the OH above, hydrogen down at carbon atom number 1. Look at carbon atom number 3 and number 4 if you are counting. Look at how they are. They are outside the ring. Look at it. Don't confuse it. That is where the students get it wrong. They forget that the L should be outside the ring. If it could have been D, it will be inside. It means the OH at carbon atom number 4 would have been up. But that is L. So the OH at carbon atom number 4 is down. The OH at carbon atom number 3 is not inside, but outside. Then, at carbon atom number 2, if it is L, the OH is to the left. If it is D, the OH shouldn't be to the right. Then put the CH2H. I said the cyclic form helps us much to understand the disaccharides, because the disaccharides have to be drawn, they have to exist in cyclic form so that it can increase their solubility. So we are going to talk about a beta D glucose, a beta D galactose, an alpha D glucose. But then the first monosaccharide component is going to determine the type of glycosidic bond which is forming. For the maltose, for example, we saw alpha D glucose, beta D glucose was making us to form an alpha 1,4 glycosidic type of bonding. So we shall have already known how to draw the cyclic form. We shall have already known what a beta D glucose is, how it looks like, what an alpha D glucose looks like, what a beta D galactose looks like. So that you can know in lactose, the beta D galactose, which forms the first monosaccharide component, will result into a beta 1,4 glycosidic bond, because it will be easy to extend it upwards since the first one has the OH above. Then even for sucrose, we'll be having an alpha 1, 2. So it is going to help us to easily understand how to draw the structure of the disaccharides after learning the linear and the cyclic form. Should I stop? I think I should stop, because it's not a matter of finishing the revision questions. It's a matter of the students' understanding. Have just passed and see this. I'm very happy student, madam. This really worked on me last semester. Thank you so much, Felista. You've come at the right time. Keep on testifying, my dear. And I'm happy. Congratulations. You did well. I'm happy so much. Thank you. We still welcome you. When you come on board to testify, it encourages the students. They will work hard, and sky is still the limit. Thank you so much, Felista. And may God bless. Just tell me which program were you? Was it upgrading? Was it EVH? Was it oral health? Good. Even the oral health says when drawing, oh no, this is somebody who is asking, when drawing the cyclic form, the OH that are to the left, is it a must for them to be in OH like in linear? Thank you, Madam Blessings. You made me trust biochemistry is easy. Welcome, Felista. We thank you so much, and spread the gospel to the other students. We really appreciate for your time. Yes, Evia Odiambo, thank you so much, you people. I want to answer tech, sites lab, then we can, oh yes, January intake. 2020, Felista, which program? Is it OH? I'm interested because I've taught many. Just tell me OH. I want to answer tech before we can go, and then we'll be able to discuss when we can finish the other ones, of course. It involves sacrifice, because even me, at this time, I would have been sleeping. But it's just an effort for both of us. And you'll eat the good fruits. You can see, I didn't even call that student here. She just came along and she has testified. And that's how God works. So whatever effort we put, even for the ones who didn't do well, don't be bitter with madam. Let us just have the positive energy, and it shall work. You know, when I teach in class, that's why I tell the students, it's easy to pass. Don't even come to me and tell me, madam, be fair in marking. I don't like that term. Because the effort which I put in the channel, I put in class for the normal lectures, we revise bit by bit. We revise before the main exam. Surely, if you don't want to pass, me, I only need a 50 or a 40 for that is. Surely. You think God in heaven will not reward us? Surely. You will pass based on whatever you put in. They even say, Whatever you plant is whatever you sow. So I'm very thankful for everything. And even for Diambo said, yes, we really appreciate. Let me answer a few which we have to. Tech Lab. I'll start with Tech Lab. Then I go to Nancy saying something. So Tech is saying something. When drawing the cyclic form, the OH that are to the left, is it a must for them to be OH like? To be HO like in linear? No, that one doesn't matter. You know, if it's in cyclic form, the position of the OH will not matter. As much as you write for me OH, even HO, it's still OH. Because even if you write it OH, how does it even connect in a linear form with a C? You know, in the linear form is where I stress, put the oxygen close to carbon. But in cyclic form, you can't limit the student how to write the OH. How will it sit? Because it has to sit like it is in, is it horizontal or vertical direction? So whether you put HO or OH, but put the OH where it exists. As long as you put it in the right direction, I'm talking about the left, I'm talking about L or D for the beta or the alphas. So if it has to come outside or go inside, that is what I check much. But in the linear form, please bring the OH close to the carbon. I think I've tried for the sites lab. Nancy Dyer is asking, does it mean the OH on cyclic form can be written as OH? Oh, you are also asking the same. So in the cyclic form, you can't limit to bring the, you know, in the linear form, it's easy to explain that put the oxygen close to carbon. But now in cyclic form, as long as you put the position correctly, if it is supposed to be inside or outside based on L or D. So I thank you all for coming, for logging in. By Friday, we'll be able to discuss when we need to proceed with the others, because I shall start on amino acids, which are the building blocks of proteins, which we'll be able to proceed with for a certain period of time, maybe for a few 3 to 4 weeks, because of the enzymes. It's a bit not wide as carbohydrates, but we shall be able to, you know, if you do the lectures in slides, it goes faster. So we'll be able to discuss. Thank you so much, everyone. I think we agreed that we stop. So we'll be able to discuss on Friday how we need to proceed with the remaining questions. But I'm happy that at least that person who did not understand now at least have a clue. You are not lost and you are not alone. Yes, thank you so much, everyone. Let us put an effort. Imagine it has worked. Do you know teaching sciences online is not easy? Just the challenge. You see, now I even had an idea I could draw and show you. With the time, as things go better, I even have a marker board here. But if I have a big camera, which I'll have soon, I can project and draw comfortably to the students, and revision can be easy. So I'm also happy and I appreciate that my students have been able to understand me and we've been managing, and it still works. You can imagine now if we have a big room and with cameras and we can project and write on the board, you can imagine how people can be really passing now. But I'm happy and I appreciate every effort. So let us put an effort. As much as I'm also putting mine, let us also come together and it shall work. We shall pass and we shall make it simple, so that you can also go and explain to other people whatever you understood, and the other people explain to other people. And now the mentality of biochem being difficult, you'll be asking somebody, what are you talking about? No. And I told you, get out of people who are saying biochem is difficult. Just close your ears. Yes, just close your ears. Quick question. When drawing the cyclic form, the OH, is this guy repeating the same question? Site lab, were you asleep and then you woke up again? Am I not understanding? Is it the question which I answered? Or I'm not getting? Science lab, can you tell us, because we are almost We are almost closing the chapter, and then you come. Is it the same question which you asked? Please clarify if it's the one which I've answered. But this one starts with a quick question. Oh, yes, it's the same. Correct. I think Odiambo has told me. So, you have a good night. May God bless everyone. And I pray that you have a fruitful week. Yes. So, bye everyone, and God bless. I don't even know where to stop. How did I even enter? Ah, yes. Now that is the class rep, Ezekiel Korir. Now I can get the name. So you can have a good night. You can just log out. I'm trying to look for this my laptop where I can log out, whether I just have to close. So it's okay. We have a good night with God's blessings.